So my question to you guys was, what does that question mark have to be in order for f, that's this dude, in order for him to be continuous? I reminded you guys of the definition of continuity. If this is true, then the function is continuous at a. And that's what we care about right here. Now, we know something special about this function. We know that we cannot plug in a 3. If we plug in a 3, we get undefined, because then we get 0 on the bottom. And so, what is this function approaching? Because whatever this function is approaching, this has to equal. That's kind of like your plan. This constant function has to equal that in order for this to work. No. Okay, so we're going to go limit. Sorry, they took way too many of my students out of here today. That was ridiculous. As x approaches 3, I need to know what this function, x squared minus 9, is doing as we get closer to 3. Because I can't plug in 3 to see what it equals. Think of it like this. From the left and from the right, we're approaching something. Okay? But I don't know what that y value is. What is this y value? That's what needs to go right here. A lot of times, calculus problems will put a k right there. I put a question mark. So you guys know that if you do direct substitution for this limit and then you get indeterminate form, then you guys can do algebraic manipulation to get your answer. Now, if I plug in a 3 to the top, that'd be 9 minus 9, which is 0. Plug in 3 to the bottom, that'd be 3 minus 3, which is 0. We get 0 over 0. That's indeterminate. So let's factor this and simplify. If I factor the top, I get x minus 3 and then x plus 3. What happens to those x minus 3s? They cancel out. And so now what I'm going to do is I'm going to find the limits as we approach 3 of x plus 3. And you guys got 6. So this number right here has to be 6. That way this dot fills in. So if I put for this question mark 6, this function f is now continuous. Let's look at a graph really fast to see if we're correct. Now, I'm not going to use a graphing calculator. I'm going to use Desmos because Desmos shows us the whole, and I really want you guys to see the whole. Okay, so here's the function right here. What's happening at 3? Oh, it looks like it's solid, huh? But if I go up to 3, we have a hole. So there's a hole right here. And what y value is this hole at? It's at 6. That's exactly what we found, right? So when I look back at my function, if I get to 3 and I say, I can't plug it in there anymore, but then I could plug it into the bottom one and I get 6, that would make that hole go away. So, yeah, so if I just go, I don't know if this works, 0, no, not 0. It'd be 3 comma 6. So now it's solid. I'd still get an open circle here, but check it out. Now I have a solid dot right there. Now this function f is continuous.